All right, hello, and welcome back to my tutorial series on the MIT OpenCourseWare course 6.837 for computer graphics. In the previous video, I showed you how to complete assignment 1, which was curves and surfaces. And today we're going to go over how to do assignment number 2, which is hierarchical modeling and skeletal subspace deformation. All right, so the first thing we need to go over is how to get the code running. This was probably like one of the difficult parts. This took some time to get working. So to start off, I have a blank folder here. I'm just going to go ahead and download the PDF. And we're going to go over basically how to get you started. And then I would recommend pausing the video and just trying to attempt the assignment. Yep. And yep. All right, save that. All right. And let's get this one downloaded. So we're going to download the Visual Studio starter code here. Save that. And I spent a lot of time going through this, and I have some steps. So we're just going to read through these steps that I wrote down, and let's get this assignment working. Cool. So now that we have the code downloaded, let's go ahead and extract this. 7-zip extract 2. All right. So the method that I did that got this thing to work was I actually created an entirely new Visual Studio project. Yep, so I'm going to click Create a New Project. Okay, and what I want is not the console app. I want an empty C++ project. So to find that, I have it on my recent, but to find that, we're just going to look up empty, and it should pop up. Empty C++ project. Click Next. Give it a name. I'll call this A2 MPC for Metaphysics Computing. And click Create. Oh wait, I want to place this in a special folder. So bear with me one moment. Assignment 2 MPC. Select folder. That's just so I can stay organized. And click Create. So as this loads up, part of the reason why I really wanted to get the Visual Studio community working is because I am actually trying out the JetBrains ReSharper program. Basically, it's an add-on for Visual Studio community, and it has some nice features that I believe they're for C#, but they also work in C++, and they really help out. I guess there's an update, but we're not going to worry about that right now. So it looks like we're good to go. So let's take a look at the checklist here, and I will make that font size bigger to make it easier to read. Step number 1, we're going to copy the source and headers. So what that means is I have my newly created Visual Studio community project, and I have the starter code downloaded. And what we're going to do is open up the starter code. And as a matter of fact, just to make this really clear what's going on, I'm going to rename this starter. So this is the downloaded, and then this is the one we're making right now. And I'm going to open this in a new window. And I'm going to open our current project. Another way of getting here is once you have your new project created, if you right click up here. Oh, no, I think it's still loading. Okay, there it goes. Right click up here, and we're going to do Open Folder and File Explorer. And then that just pops us right into where our project is being saved. Cool. So that first step, we are going to copy the source and headers over. All right. So if I pop into the downloaded starter code and I sort by type, I should have muted my phone before starting. Sorry about that. Okay. Sort by type, we can see we have some C header files and some C++ source files. We're going to go ahead and get all of the header files and source files, and we don't want to move them. We're going to copy and paste them over here. Cool. So now they are in our project directory, but they haven't been added to our project yet. But that's okay, because the other thing, I have it on a second screen over here, but I should show you guys as well. So we just finished this step, and next step we're going to copy over vecmath and the data directory to the project directory. So it's talking about vecmath right there, and the data folder. We'll copy these guys, and we're going to just bring them over here. Excellent. So now we have those. And what do we have next? So that is done. Next up, we're going to include the source and headers to the project. So the way we do that is we're going to start with the source files back over on Visual Studio Community. If you right click on this and go to add, and then we're going to do new filter, and let's call this vecmath, enter. Now right click on this newly created vecmath filter and right click on it and go to add, and then click on existing item. Now inside, so it opens up our project directory, and we can see where we copied over all the source files and vecmath and data. Let's go into vecmath, and we have two folders. There's the include folder and a source folder. So let's go into the source folder, and I'm going to push Control A to select all of these guys, and I'm going to click add. And so now we have the source files added to vecmath. Now we're going to click on the parent folder. So you can see there's like a parent-child relationship going on here. I'm going to close the vecmath folder, and we're going to right click on source files and go to add and get existing item. And it put us in this vecmath source folder. We're going to go back out to the project directory. And once again, on this type column, we're going to click that so it sorts by type. And we don't want the header source files. We want the C++ source files. We're going to get all of these guys. So I'm going to click the first one and then hold down Shift and then click the last one, and I can select all of these guys and everything in between the first and last one. And we'll click add, and it takes a minute to, oh, that was pretty fast. Okay, so now we have vecmath. Inside the vecmath filter, we have all of our vecmath CPPs. And inside our source files, we have all of our starter code source files. So this is all good news. I did not mean to open that up. Let me close that down. All right, so next up, we're going to add in the header files. So we're going to go to add, and we're going to do a new filter. And this is also going to be vecmath. And we're going to right click on vecmath and go to add, and we're going to do existing items. And inside vecmath, inside the includes folder, we're going to push Control plus A, and that selects everything. Click add, and there they go. Cool. Yep, there they go. Sorry, I was looking in the wrong spot for some reason. Okay. Now on the header files, we are going to right click on the header files and make sure you're not clicking on vecmath. Make sure you right click on this guy. I don't think it makes a difference using the filters. It just makes it a lot easier to know which code is for what by sorting them into these filters. So we're going to go back to the parent directory, and this time this is when we want the C source, the C header source files. I don't like that it calls it a header source. That doesn't make any sense. It's a header file. All the files ending with .h. So we'll click add. Excellent. So we have now included the existing source and headers to the project. Let's give that a check mark. And now we have to add vecmath includes folder to this VC++ includes directory. So what this means is, even though, and we're not going to build yet, it's going to give an error. So even though we have these items added to the filter, when we hit play, or if we try to build, it's only going to build the things that it sees in the project directory. And if you notice, on our project directory, we have VecMath as a folder, and tucked away inside this folder is an includes folder and also a source folder. So when we hit play, it's only going to look in this folder, everything in this folder. It's not smart enough to look inside these folders as well. So we have to tell it to. So that's what this next step is going to do. So in order to tell it to look inside these folders for more things to compile, we are going to, there's two ways of getting there. I think the more reliable way is on this local Windows debugger. If you click the drop down, there is the A2 MPC debug properties. Another way is to click this top, what is it? I forget what that's called. Is it a solution? I don't remember. Add. Oh, it's a project. Yeah, it's a project because you can add more projects to a solution. Okay, anyways, you click this guy up here and you right click, but make sure you have this guy selected. So if you have this guy selected and then, oh, I guess it does retarget. Okay, never mind. We're going to right click, and if you go all the way to the bottom, there's properties. Okay, and one thing I ran into is, like, after coming in here and coming out of there, if you have something else selected, it says there are no property pages for this selection. So make sure you have this very top guy selected so you get the properties for the entire project. And that's why I'm saying the more reliable way is to come up here and click this drop down and do that. Okay, anyways. So we can see there is a category for VC++ directories. Let's click on that. And there is this include directories under general. We're going to click the drop down and click on edit. And we're going to click a new line right here. And then we have these three little dots on a button. Let's click that. And then this is where we can specify, what are we specifying? The VecMath includes folder to the includes directory. So inside VecMath, there's the includes folder. And so now we have includes typed in down here, and we have the path up there. We click select folder, and it will automatically type in that entire path to get to here on this entry. So you just click OK, and we just finished that step. So add VecMath includes folder to the, yep, that is done. Cool. Next up, we're going to add VecMath source folders to the VC++ includes directory. So that is actually a mistake. This should be to the VC++ source directories. It's just from copy and pasting. So we need to actually add the source folder to the source directories. That makes more sense. So once again, we find source basically in the same panel that we were already looking at. Find source directories, click edit, click the little folder icon, click the three dots. And now we go into VecMath again, and this time we want the source folder. We'll click select and OK, and that is done. Okay, now in order to resolve some of the library dependencies, there is this library called FLTK, and we're going to have to download and build it. I'm not going to get into too much on FLTK, but if you notice in our starter folder in the lib, it's asking, or it gives us a FLTK.lib and all of these different lib folders. Couldn't get it to work using the ones that are downloaded and included in the starter code. I had to basically do it myself. So I didn't really question it too much. This worked, so as long as it gets you started on the project, I don't think it really makes a difference. All right, so we're going to navigate to FLTK.org/software. I believe this is still being maintained, so if we take a look at the date, there should be a date somewhere, maybe on the forums. I believe they're still maintaining this. I mean, it says copyright to 2021, so that's this year. Well, in any case, we're going to navigate to the downloads page, and we're just going to get the latest version. And I am going to get the, what's the difference between these two guys? Oh, BZ2, so just two different types of compression. I don't remember which one I got, but Let's just get this very top one. Pretty sure it'll be fine. And I'm going to put that in my folder containing my starter code, the downloaded starter code, and my project. I'm just going to save it there. Yep. Show in folder. Show in folder. There we go. All right. So, okay. Sorry, I'm a little bit distracted by my phone there. Okay, so now we got this downloaded, and the program I am using to extract this is 7-Zip. Super recommended. Free program for compressing or uncompressing files. If you don't have it, I super recommend it. It's open source. None of this WinRAR crap. It's the real deal. Anyways, if you don't have that, go ahead and download that, get that installed. And what it lets you do is if you right-click on this, you have the 7-Zip option here, and then I just click Extract to FLTK 1.3.7-source.tar. Click on that, does its thing. So now that gives us this new folder, and inside here, there's another thing to extract. It is a tar archive. So right-click on it again, and then with 7-Zip, we're going to extract to FLTK 1.3.7-source. Excellent. And let's see what our next steps in the instructions are. So we went to that website, and now we're going to navigate to this folder and launch the Visual Studio project. So we come in here, and we go to the IDE folder. And there should be a Visual C 2010. We'll click on that, and we are going to look for a solution. So this is a solution. All of these projects are in this solution, so we're going to launch this solution. Might take a minute to start up. Excellent. So when you get to this screen, it wants to retarget. So basically it wants to upgrade the 2010 version to the latest. I'm on 2019. So I'm just going to click OK, leave it all default, and click OK. And we just finished that step. And then the last step is going to be to switch it to release and then build the solution. So you can see it's upgrading. I'll fast forward this part if it takes a long time. Okay, we're back. And so the next step we have to do is to set to release and build the solution. So all we have to do is, okay, hopefully that's not going to cause me problems. We're going to come up here, and I just saw something blinking down there. We're going to come up here and switch from debug to release. And then what I'd like to do is click on build and then click build solution. And this is going to go through and build all of the libraries included in this FLTK library. So I'm going to go ahead and pause the recording again, and we'll come back when this is done. Okay, I'm back. So we have 79 succeeded, 0 failed, 0 up to date, 0 skipped. This is good. I made a quick note. The first time I did this, I did not get 79 success. So if you run into that, here's what you got to do. So this is good. I have 79 succeeded, so I'm not going to actually go through with this step all the way. What you got to do is you have to close down that project and wait for it to unload everything. And then back in this FLTK library folder, went in the wrong spot. Under the one you were running, I have this hidden folder here. It's called .vs. If you don't see it, if you go up to View, there is this checkbox for View Hidden Items. Have that checked and you can see this. If you go inside here, and then go inside here, and then go inside here, there is this .suo. For some reason, if you just delete that, so just hit the delete key, or if you're afraid of deleting it, you can cut it and paste it somewhere else. Just get it out of this folder and then repeat this step again. So go back into here, find the solution, launch the solution, and switch to release and build it. All the steps we just did, then it worked. So hopefully everybody is still with me and everybody got success. If not, I'm sorry. I could try to help in the comments, but this was really, really difficult to get working. So it's a little bit of luck involved to get this assignment running. Okay, so we have built and we did it in release mode. This step is completed. So now if we come back out to the main library directory, one of the things we got, let me see if I have a note. I know I made a note of this somewhere, maybe not. There is this examples folder. Nope, not the examples folder. Is it the test folder? Yeah, it's the test folder. So if you go to the test folder, there is all of these applications that just got created, and you can kind of go through and check out these applications. So here's one on fractals. Let's take a look at that. I don't really understand this one. I guess it's using fractals. The tree doesn't look like a fractal to me, but I can definitely see a fractal on the island. I can see a fractal on that. And yeah, you know what? I mean, I've done Barnsley's Fern before, so maybe there is some sort of fractal thing going on here. I'm pretty sure they have the Mandelbrot set on here. Yep, Mandelbrot. So this is cool. This is the Mandelbrot set. And what FLTK does is they are giving you the ability to use C++ and create these windows and also use OpenGL natively. So I'm a fan of this Mandelbrot set. I actually had to program this myself using C# for a college assignment. But and it was scary how similar the requirements for my assignment was to this program. I was like, I could have just stolen this program and turned this in or something. But anyways, if you click and drag, you'll zoom in. And the interesting thing about the Mandelbrot is, man, I don't really remember the definition. I think it's something to do with like, it's the set of Julia sets or something. But you can just keep zooming in infinitely. And I've already looked at this demonstration. So like as you start to zoom in, I believe it should have infinite precision, but after some time, it seems to start getting fuzzy. I haven't studied this enough to really know why. But yeah, in like the 80s and the 90s, well, I don't remember exactly what decade, they were pretty excited about this stuff. And then you can change the iterations that this takes place on. Yeah, there you go. So now you can see, again, some interesting patterns to zoom in on forever. Kind of reminds you of maybe some sort of like sea creature or something. Oh yeah, here we go. So it turns into pixels for some reason. That could be just the way they implemented it in this program. There's limitations, but I've seen other videos. You can go on YouTube and you can see these really great visualizations of the Mandelbrot set. And like they have some, I believe there's one on YouTube that's like zooming in on the Mandelbrot set for 30 minutes. And they have like really pretty colors and all sorts of stuff going on. So anyways, enough of that. Let's close this down. I encourage you to take some time and look through this test folder and see if you can find something interesting. The FLTK library, I believe, has been around for a long time, so some of the stuff in here is kind of like not as impressive. Like you saw that fractal tree thing, that looked like some horrible graphics that are pretty dated at this time, but you know, you can imagine, like, if it was 2001 and you saw that, you'd be like, oh my gosh, what the heck? This is cool. Right, so let's get back on track here. The next thing we want to do is we're going to copy the free glut.h from GL and starter code to the GL in our library that we just compiled. So on the right, I have the library that we just compiled, and you can see in this lib folder, we got some libs, and they kind of look familiar to these libs, right? We have the FLTK lib, but this was created just now, and this one was created in 2012. So you can kind of see where we're going with this. Anyways, we want the free glut.h from the GL folder. So let me get these guys opened up, and we're going to go into the GL folder. If we go to our GL folder, I just have the GLUT. And so we're going to get all of these guys, and we're going to copy all of them, and then we're going to come over here and paste all of them. Cool. And so we just did that. Now we're going to move from the starter code the free glut.lib into the FLTK lib. And I should have done this step because I was just in those libraries, or in those directories. So all of these are FLTK. There's a readme.lib, which is kind of strange if you try to open this with Notepad++. I think it's still in binary, sort of hex file. Of course, it would help if my computer wasn't going so slow. Oh yeah, it is a straight up readme. Cool. Anyways, we don't care because we just compiled it ourselves. We just want this free glut.lib. So what I found was it wasn't necessary to do free glut from scratch. I just did the FLTK, you know, from source, I should say. Anyways, that step is done. All right, let's keep pushing through. Now we're going to add linker additional dependencies to point to our FLTK lib directory. So what that means is we're going to go back to Visual Studio Community on our project here. And we are going to open up the linker additional dependencies and point it towards our lib folder. So under these linker options, I believe it's under General. Additional library directories, I believe, is what we want. I hope I'm not mistaken. Okay, I'm back, and yes, we're in the right spot. I had to open up my my project that is the completed solution just to make sure. Okay, so we're going to create a new line, and we'll click the three dots. And we're going to go up a couple of levels. And there is our FLTK. You're going to have to navigate to wherever you downloaded and extracted and built your FLTK library. But mine is in the same folder with the starter code and the code I'm currently developing. So open up that and keep clicking, and we're going to, what is it, the lib? We're doing the lib, right? We're doing the lib. So we're going to select the lib, select folder, click OK, and we finish that step. Next step, we're going to add the FLTK directory where you can see FL and GL to the VC++ include directories. So what that is talking about is on VC++ directories, on the include directories, we're going to click this edit and click this and click the three dots. And what we want to do is go up to our FLTK library, go into here, and this is exactly where we want to be. We want to have the FLTK library. We want to be able to see the folder GL and see the folder FL. And I will explain why after I click OK. So let me close this down for a second. If you take a look, we see some includes going on here, and they're actually using relative paths. So they're saying quotation marks, which means include this header file from my current working directory. But on top of that, they're specifying also from my current working directory, look at the GL folder, and inside the GL folder is the free glut.h. And it's there because we just pasted it in there. There's also the gl.h in the FL folder. So in the FL folder, we have there's a lot of stuff in here, a GL header file. So that should make sense, what I just explained. So we're giving it the folder containing FL and GL so that you can use that relative referencing in your includes. So that's done. Next step, we're going to do add the FLTK src source to the VC++ library directories and source directories. Why did I say libraries? Library directories. May need to pause the video just to verify that. Sorry, I wrote these notes last week, and so some time has gone by since doing this the first time. So let's go back into the properties panel. Properties. And under the source directories, edit, new folder, navigate to it. This is going to be our FLTK library, and it is the src folder. Select this folder, okay, and then under library directories, I believe, okay, we're back. So I don't think we have to put this here, but let's just follow my notes. Bear with me. I think this might be an unnecessary step, but there were several things in here that I really wasn't sure what was the thing that made this work. So when I'm looking at this doesn't make sense to me, but let's just follow the notes. It says to go into library directories under VC++, and we're going to add the FLTK source folder to that. This might be unnecessary, but I'm going to go ahead and do it because we just want this thing to work. So that step is done. What does make sense to me is putting the source folder in the source directories. That definitely makes sense. This part doesn't quite make as much sense to me, but rather than trying to figure it out right now, I'd rather get this video out. So, all right. Now, the next thing we're going to do is under the linker. In the general, we had already specified that we want additional library directories, and we are navigating to our FLTK lib folder. So now under input, we're going to go to additional dependencies and click on it and click this drop down arrow and click edit. And now we have to type in the libs that we want to use. And sorry about that. I just got an email. Let's go ahead and mute that. Cool. We're going to do FLTK.lib, FLTK.gl.lib, and free glut.lib. So that is FLTK.lib, FLTK.gl.lib, and free glut.lib. Make sure I got that right. Yes. Click OK. Click Apply just to save those changes, and check that off. All right. Next up, we're going to add this line of code, a preprocessor directive, setting this to 1 to all the crybabies. So when I did this, I was a little bit upset that it wasn't working, and so I called all the things that wouldn't compile crybabies. But let's click OK. And if we try to hit play, I believe we want it in release. May not want debug mode. Might have to switch to release mode. What did we have on A2? Oh, did I put this in debug mode? I don't even remember. Well, we'll find out. We'll find out. So we're compiling things. Things are happening. I don't think this will take too long. Got some errors. So we go to the error list, and yes, so these are the crybabies. All of these CPP files are using functions or variables that may be unsafe. We're using some very old code. It's like 10 years old, this starter code we're working with. So here's how we can fix it. If you simply put this preprocessor directive at the very top of every file that did not compile. So I have this error list. By the way, if you don't have this error list, you can get to it by going to, View, and then error list. There it is. Click on that. Brings up this window. Also notice I am hiding the warnings. I don't care about warnings. Warnings aren't going to stop us from compiling and running our project. So we just did bitmap.cpp. That only needs it one time. It has two different cases where it messed up, but it only needs the preprocessor directive one time to fix that issue. Now let's go to modeler UI.cpp, and I'm going to go to the very top. And I'm not even going to push down this comment. I want that to be the very first thing that this CPP does. So I'll put it at the very top there. All right. Next up, we have main.cpp. Let's go to the very top, push everything down, and paste it right there, and save it. Cool. And then next up, we have modeler app. So I'm just double-clicking the error to open the source file that is the complainer. Cool, save that. So that is looking good. Now the very next thing we're gonna do, two things we're gonna do left. We're gonna do a post build event, and I'm actually gonna highlight this. And you can pause the video and get that copied, typed out. Hey, I don't have a step here. Okay, so we're going to use inside our project directory the free glut.dll. We forgot to copy that over, so we're going to also copy that over to our project folder. Don't worry, I have to do it as well, so just bear with me one moment. So what we need to do is go into our properties. And down here on build events, we're going to do a post build event. And where it says command line, we want that command right there. Cool. Click OK. All right. So now to copy over that DLL, or the dynamically linked library, we need to navigate to our folder inside File Explorer. And we're going to actually get this guy from the starter code. So where's my starter code? I don't have, oh, this is the starter code. All right, here's my starter code that I downloaded from the MIT website. We're going to copy this free glut.dll, and then we're going to come over to our project and paste it in there. Excellent. And this step is done. Now the last step, on the debugging, we're going to add a command line argument. We're going to use inside the data folder model1. And so we're going to go into properties, and then under debugging, and sorry, what am I doing? Command arguments. We're going to say data/model1. So what I just did here, and this should look familiar if you did assignment 1 in my previous video, we're basically giving a command argument to the executable of our project. So it's going to say, okay, look inside the data folder and try to find model1. Cool. And that is all of the steps to get this thing to work. All the steps described, the necessary steps to get the MIT 6.837 assignment 2 starter code to work in Visual Studio 2019. So let's see if this thing works. Moment of truth. This is good. And there you have it. This is a success. So as you can see, we have our OpenGL window here with some sort of 3D coordinate system going on, and we got this nice control window over here. Everything's working perfectly, and this should be a consistent method for you all to get started on this assignment too. So at this time, the length of this video is running a little bit on the long side, so I think what I'm going to do is cut the video off here, and this will just be how to get the starter code to work. And in the following videos, I will show how to actually get the assignment done. And as a sneak peek, I already have the assignment completely finished, and I can kind of demo that for you right now. And what you're about to see actually took 60 hours worth of work to get this, for me to get it to work. Part of that is due to I don't go to MIT, and I did not have a professor I could talk to. There were no teacher's assistants I could talk to. It was literally just me trying to knock this out myself. So in a way that made it more time consuming and a lot more difficult. I definitely got stuck on, what did I get stuck on? One of the hard parts I got stuck on was getting the bones to actually line up. So I had it to the point where I could move the bones all to the correct size and have them all pointing straight out on the z-axis, but getting them to turn and point to the next joint in the skeleton was pretty difficult. And if we hit the S key, the skeleton is no longer drawn, and now we have this nice 3D mesh. And if we go back to the skeleton, what I can do is if I can grab this right knee and kind of angle it. My code runs a little bit slow. I believe there is some optimizations I can make to make it run smoother in real time. But now here's the other impressive thing. If I turn the mesh back on, the mesh actually deforms with the skeleton. So the bones are underneath, and all of the mesh is drawn relative to the bones. And there's a whole bind position. I super recommend following along with the lectures. I'm not going to teach the stuff that is taught in the lectures, but it's definitely required to get this assignment to be done. And one of the interesting things about the lectures was, by the way, thank you to my viewers who pointed out to me that the lectures are posted on YouTube and you can watch them for free. That was super helpful. One of the things he says is like, it's really easy to listen to this lecture and just kind of let it wash over you. But he said it's good to really get active and think about the things that he's talking about. For me, what I found was like I just kind of watched all the lectures for this topic at like 1.5 speed, playback speed, or double the playback speed, and just to get an idea of the things that he talked about, because he does kind of show some animations that's not going to help you get this project done. And then when I set out to actually do this code, which we'll do in our next video, what I found was I would get stuck on something, and then I would go back to the lecture again, having the context of what am I stuck on. And then as soon as he starts talking about the thing I'm stuck on, then I really pay attention and I slow it down, because now I have, the context and the motivation to listen to what he's saying. Because the lectures are 75 minutes and it is very math intensive. So with that said, I think I'm going to go ahead and end the video here. Thank you so much for watching, and stay tuned for the next one. Good luck, guys.